Lep pozdrav še enkrat iz snežene Ljubljane. Moje ime je Urban Brodnik, na Špici pokrivam področje sledenja in označevanja, pa tudi skrbim za uspešnost tega področja. Z mano bo danes še kolega iz Sevija, Martin Kostka. On je zadolžen za razvoj projektov na območju jugovzhodne Evrope, torej pomaga nam v predprodajni in tudi poprodajni fazi RTLS projektov, prihaja iz podjetja Sevijo. Torej danes vas bova midva vodila čez ta webinar. Še to, sedim v svoji improvizirani pisarni, ne mi zameriti, če se bo slišal trušč otrok, ko skačeta v sosednji sobi. Še nekaj osnovnih napotkov. Trenutno so vsi na mute, tišani, da ni preveč šuma. Vprašanja so več kot zaželena. Prosim vas, da jih sproti pišete. Najprej kliknete na puščico, mislim, da bi mogli videti desno zgoraj na zaslonu in potem v polje questions vnesete vaše vprašanje. Na koncu bo seveda z Martinom nanje tudi odgovorila. Evo še agenda predstavitve. Na začetku bom predstavil tehnologije za lociranje v zaprtih prostorih. Bolj podrobno se bom ustavil pri UVB tehnologiji, torej ultra wideband. Potem pa bo Martin prevzel besedo in predstavil Sevija RTLS platformo, pa tudi primere z prakse. Na koncu, kot že rečeno, še Q&A. Evo, Martin je tudi že z nami. Hello, Martin. I suggest you do... še to. Torej, moj del bo potekal v slovenščini. Martin je iz Češke in bo seveda v angleščini predstavil svoj del. So, hello, Martin. Could you please just shortly introduce yourself?
Yes, good morning. My name is Martin Kostka. I represent a company called Savio Networks. We are based in the Czech Republic and we operate globally. I've been in the business of RTLS for, well, a couple of years now. And I'm very happy to be here with you today to talk to you about what the platform that Savio provides can do, and give you a couple of examples of how our customers, through partners such as Spitza, have already brought some benefits. Yeah, they have utilized the platform to get a lot of insight into how their processes work and so on and so forth. So super excited to be here. And I'll mute myself until the time you say, go ahead.
Yeah, I will give you the sign. Tako, super, evo, jaz nazaj prevzemam vajeti. Za lociranje v zaprtih, pokritih prostorih sta dve večji skupini. Prva temelji na radijskih valovih, druga skupina pa na optični in slikovni tehnologiji. Danes se bomo bolj posvetili prvemu delu, torej radijski tehnologiji, saj se ta precej bolj pogosto pojavlja v industriji in tudi realnem svetu. Optična in zvočna tehnologija je bolj takih specifičnih okoljih. Bluetooth je prisoten v vsakem žepu, vsi ga imamo na telefonu in je posledično zelo pogost. To je tudi ena zelo močna prednost tega sistema za lociranje. Razmeroma enostavno ga vzpostaviti, lahko teče v celoti na baterijah, kar je lahko prednost, torej enostavna montaža. Ena taka tipična aplikacija, kjer se uporablja Bluetooth tehnologija za lociranje, je prikazano na desni sliki. Torej tole vidite zaslon, kako lahko Bluetooth tehnologija navigira v zaprtih prostorih, torej je gateway letališče in usmeri uporabnika pač do želene točke. Pomanjkljivosti Bluetooth tehnologije za lociranje je to, da za koliko pametne podatke potrebujete ogromno Bluetooth beaconov. Druga slaba stran je, da so moči oddajanja signala razmeroma šibke, kar pa daje tehnologiji omejen doseg oziroma mora biti zelo veliko teh beaconov postavljenih. Slaba stran je tudi to, da teče na baterijah. Torej, prej smo rekli, da je dobra stran, lahko je tudi slaba. Torej, morate imeti nek battery management, da vam sistem stoji, torej, da vsi beaconi stojijo po koncu, da vse značke, da imajo napajanje, tiste, ki niso na telefonu. Bluetooth bazira na RSSI tehnologiji, torej Receive Signal Strength Indicator. O sami tej tehnologiji nekoliko več kasneje. Glavno pa je, da ta tehnologija nima največje natančnosti, tam nekje od 3 do 5 metrov, torej razmeroma slaba preciznost, pa tudi občutljivost na kovine. Z angle of arrival je možno nekoliko izboljšati samo natančno zaznave. To pomeni, da lahko senzor, ki prejema signal iz značke, tudi določi kot, pod katerim prihaja ta signal. V tem primeru je potem natančnost, ločljivost nekje 1 meter. Problem pa je, ker potrebujemo v tem primeru ta clear line of sight med senzorjem in Bluetooth beaconom. Slabost tega pa je, da natančno začne z oddaljenostjo zelo padati. Kje se uporablja ta Bluetooth, kot rečeno, že trgovski centri, letališča, zdravstvo, konference. To so primeri, kjer natančna pozicija ni toliko pomembna. Bluetooth tehnologija se pa lahko uporablja tudi za zaznavanje prisotnosti. Recimo imaš en Bluetooth beacon in z njim preverjamo, ali je v bližini kakšna oseba. Torej, ne poznaš točne lokacije, ampak samo ali je oseba v prisotnosti tega senzorja. To izkoriščamo tudi mi pri nekaterih naših rešitvah za registracijo delovnega časa. Zaposleni ima telefon, bi se to neke vrste terminal za registracijo, Bluetooth beacon pa je značka, ki določa točko registracije, ne vem, vhod podjetje, vhod v proizvodnjo, tako naprej. Wi-Fi tehnologija, pomembna prednost pri lociranju z Wi-Fi-jem je tudi ta, da so značke lahko kar naši pametni telefoni. Druga pomembna prednost je tudi ta, da lahko vašo infrastrukturo pod določenimi predpostavkami kar uporabimo za samo lociranje. Torej, obstoječ Wi-Fi pa še dodamo kakšne točke in že lahko uporabljate lociranje. Slabosti na drugi strani pa so, da ima Wi-Fi razmeroma veliko moč oddajanja signalov, to pomeni veliko porabo energije. Torej, če so značke brez zunanjega napajanja, to pomeni, da jih bo treba se več s tem ukvarjati z baterijami v teh značkah. Druga slabost je ta, da če uporabljamo pametne telefone za lociranje, so osvežitve lokacij zelo naključne, torej odvisne od tipa in znamke naprave. To je lahko tudi samo 3 do 5krat na minuto, kar pa v bistvu ni pravi RTLS. Druga slaba stran je, da potrebujemo razmeroma veliko Wi-Fi senzorjev, torej postavitev, po drugi strani vse ni tako enostavna, ne? Ni kar to, da bi vašo obstoječo Wi-Fi infrastrukturo uporabili in šli. Vse je tukaj lociranje na podlagi triangulacije, torej vsaj 3 točke za vsako mesto, kjer želite locirati tege. Tudi ta sistem bazira na RSSI, to pomeni, kot smo že prej rekli, slabo preciznost pa občutljivost na kovine. Tudi ta Wi-Fi lociranje se tipično uporablja zelo podobno kot Bluetooth, torej konference, pisarni, zdravstvo, trgovski centri, take stvari. Lociranje s pomočjo RFID-ja. Verjetno ste se že vsi srečali z RFID-jem oziroma ste že slišali zanj. Na Špici imamo vedno več projektov na to temo. Včasih se je o RFID-ju zelo veliko govorili, malo delali, zdaj je ravno obratno. To pa je tudi glavna prednost te tehnologije. Vsi jo poznamo, dobro ima prepoznavnost, kar pa v bistvu posledica standardizacije tehnologije. Za naše projekte mi uporabljamo reader enega proizvajalca, anteno drugega proizvajalca in tag tretjega proizvajalca in vse skupaj zelo lepo sobiva med sabo. Zdaj, da bi RFID tehnologijo uporabljali za zelo natančno lociranje in pa v realnem času, se mi niti ne zdi smiselno. Torej, največja uporabnost RFID tehnologije v oskrbovalni verigi je v tem, da lahko z njo identificiramo več izdelkov hkrati, ne da bi jih videli. Recimo, da želimo beležiti, koliko kosov artiklov je prišlo skozi določen prehod, ali pa kateri artikli so v določenem paketu. Torej, ne rabimo skenirati vsakega posebej, ampak lahko to avtomatiziramo. Torej, pri RFID-ju niti ne določamo pozicije, ampak prisotnost določenega predmeta pri prehodu skozi anteno. RSSI, Receive Signal Strength Indicator. Vse te tehnologije, ki smo šli zdaj skozi, RFID, Bluetooth, pa tudi Wi-Fi, bazirajo na RSSI. Torej, senzor na podlagi jakosti signala določi oddaljenost značke. Značko daje signal, ko pride do senzorja, senzor ugotovi jakost, izmeri jakost signala in določi, kakšna je ta razdalja. Na spodnjem grafu je vidna glavna slabost oziroma omejitev te tehnologije. Večja kot razdalja med senzorjem in značko, torej na X-osi je to vidno, bolje krivulja jakosti signala vodoravna. To pa pomeni, da je tako vse težje locirati. Vidimo tudi, da so te meritve precej različne, torej modre pike te zvezdice nihajo gor in dol. To pa pomeni, da je tehnologija precej nestabilna in ne omogoča natančnega pozicioniranja. Zdaj, če natančnost, nekaj metrov, 3 do 5, potem je RSSI spremljiv, kar pa v oskrbovalni verigi navadno ni tako. Še ena pomembna slabost RSSI tehnologije, ki do zdaj nisem omenil, je, da uporablja frekvenco 2,4 GHz, ki je precej zasedena. Torej tudi recimo mikrovalovne pečice se nahajajo tu. Ravno danes sem na Siolu videl en članek, kjer je pisalo, da mikrovalovna pečica lahko močno poslabša delovanje Wi-Fi signala. Evo, ne? Torej take interference lahko vplivajo na delovanje. Pa tudi še mnogo drugih tehnologij, mnogo drugih naprav uporablja to frekvenčno območje. Ultra-wideband, torej tukaj bo danes fokus, deluje na drugi frekvenci, in sicer 3 do 7 GHz, kar je že pomembna prednost te tehnologije, torej da ni nekih interferenc z ostalimi tehnologijami. Torej ultra-wideband uporablja time of flight, torej ta sistem ne beleži moči signala, ampak čas potovanja signala. To pa močno poveča robustnost in natančnost sistema. In ta način uporablja tudi Sevio platforma za lociranje v prostorih, o čemer bomo več slišali od Martina. Pomembna prednost je tudi ta, da je moč oddajanja blizu šuma, kar je tudi ena prednost, torej specifična prednost ultra-wideband tehnologije, saj v tem primeru ne prihaja do interferenc z drugimi tehnologijami. Lociranje z ultra-wideband tehnologijo. Prednosti so visoka natančnost lociranja, povprečje v industriji znaša nekje 30 cm, odvisno, kako pogosto so senzorji postavljeni, kako nagosto skupaj. Pomembna prednost je, da deluje tudi v zahtevnih industrijskih okoljih, torej tam, kjer je veliko kovine. Locirati je možno tudi nekaj desetkrat na sekundo in zato dobimo zelo realne podatke o lokaciji in tudi o sami poti gibanja. In glede na to lahko govorimo o resničnem lociranju v realnem času, seveda. To, da ni interferenc z drugimi tehnologijami, sem že omenil. Zdaj slabosti tehnologije pa so, da potrebujete novo infrastrukturo, torej te senzorje ali ankorje, v angleščini moramo seveda postaviti, da lahko sistem teče. Ta druga pomembna slabost je tudi ta, da tagi niso ravno poceni, kot so recimo to pasivne RFID značke. V začetku leta sem v monitorju zasledil en zanimiv članek na temo UVB-ja, in sicer Apple v iPhone 11 že vgrajuje UVB čip, torej to pa pomeni, da UVB prehaja tudi masovno uporabo, recimo za navigacijo znotraj prostorov. Še bolj zanimiva je pa stvar, torej veliko boljše bo možno zaznavanje prostorov, torej za pametne zgradbe. Soba se bo znala prilagoditi na vas, ko boste stopili vanj, recimo luč se bo zadimala, glasba prižgala, računalnik se bo vklopil in tako dalje. Nekaj podobnega pripravlja tudi Google za Android telefone. Zdaj, a bo zadeva zaživela, pa je po mojem predvsem odvisno, kako bodo uspeli vse skupaj standardizirati, pa koliko aplikacij bodo znali sestaviti in pa koliko bodo te uporabne za nas potrošnike. Skratka, tehnologija se razvija, ne samo v profesionalni uporabi, ampak tudi na čist taki consumer plati. Evo, sedaj pa bolj natančno o Sevio UVB RTLS. Martin, are you still here?
Yes, absolutely.
Perfect. So the floor, actually screen is yours. Now it's up to you.
Perfect. So ladies and gentlemen, I will want to expand on what Urban has already talked about. Thank you very much for the introduction. I'll try to be as brief as possible. I'll just try to expand slowly and not in much detail on what was already said about the technology, but I'll try to tell you at least one or two stories about how customers have benefited from utilizing what Sevio has to do. So just a couple of words. Czech company based in 2014 by two people, two doctorate students who thought ultra wideband was so cool that perhaps a company could be built around that. Since then, we've successfully done more than 350 installations throughout the world. There's 25 people working at Sevio at this moment, and Spitza is one of the 70 partners that we have worldwide. So what do we do? You've already heard something from Urban already. So let me expand on that. We do a system, a platform that is called Sevio Real-Time Location System. And it consists of hardware components and software components. And the whole solution does something very simple. So what you have is objects of interest. They can be pallets with material. They can be forklifts. They can be people. And those objects are equipped with a small device called a tag. And the tag does one simple thing. It just sends a signal. And the signal is transmitted to the air. And the infrastructure that is installed within the building tries to listen whether it can hear any signal. And if it does, it sends the information to the server. Now, the server is capable of communicating with the anchors. And once the signal is received from multiple anchors, it is sent to the server, and the server calculates the location of the object. It's very similar to GPS that you know very well, because we use GPS in everyday life for navigation and so on outdoors. So it's a very similar system, but it works indoors. And the big difference is that the communication happens in the other direction. But what is very important is it is very precise, as Urban has already talked about. What is the biggest beauty of the whole system for our customers is they can have the precise location, but the precise location on its own doesn't mean much. But when we turn that location data into valuable information, such as where was a pallet with material or produce, and when it has left a particular area, then we can base information about the processes in real time based on the location data. So that's the whole beauty, and I think it's quite simple, but at the same time very powerful. As the production happens in real time, very often the information is delayed. With this system, it is there and immediately. So this is just for your imagination how the system actually looks like. We are tracking, for example, in this case, a forklift, and as it is moving through the facility, we are capable in real time to see where it is going very precisely. And as you can see on the bottom of the screen, it is going through particular zones that we are tracking and basing our processes on. So what are the typical problems that we try to help our customers with? First is customers tell us they are blind. They do not see what is happening in real time in their factory, in their warehouse, in their facility. If they have information about something going wrong or something not going according to the plan, it's usually with some delay, and that is not what is required at this age. They really want to see it in real time. The second big problem is they cannot find something. One would think that today everything is digitized and all the systems are keeping up with today's requirements for just-in-time production and so on and so forth. But very often the reality is that things get misplaced, and people spend a lot of time even wasting their time by trying to find something, a component, a batch, something, and they really cannot find it. So when we can help them with locating the objects and showing where they are, they can reduce such loss of time. And third is, and I already covered that to a certain extent, is customers tell us that they would like to make decisions in real time. For example, there's something missing and they need to produce one pallet extra or something like that, but they do not have the data in real time, and therefore they cannot make decisions in real time. They can only make decisions to improve in the future. And those are the three big areas that we try to help our customers to improve with. So what are the benefits? First is really there are immediate, meaning real time and correct data, because we also try to minimize the human error that is connected with data entry. And this helps managers to shorten the time that they need to make decisions and changes. There's less paper used as we try to digitize the entire process. And there doesn't need to be like dispatch notes or sheets of paper that people take notes on what has happened in the production. And also, I already covered that, a little less room for human error. No more barcode scanning or less of that, and no errors in terms of data entry into various systems, warehouse management system, ERPs, you name it. Last benefit I would say that there is definitely this location data becomes one source of truth. So there are no assumptions, meaning that people really will know, and everybody will be working with the same set of data. So how does the solution really can look like? What does the customer can see? Is something like this. It can be a system that shows the planning of the production as the batches were planned, and then comparing it, for example, with the reality, so that the planning can happen better next time. We have done, as I said, more than 350 customers in this presentation. Some of the big names you can see, even you may recognize. Predominantly, it's in industry, tracking material, tracking logistics, and sometimes we do track people for process optimization or sports as well. So I'll talk to you about two customers today. One is in the intralogistics, meaning that we are tracking their forklifts. It's a Czech company, but with worldwide reach, but Budweiser Budvar. And They have a big warehouse where they have lots of beer, and the problem was that they had a system that was giving them some information about location, but the problem was that it was not very reliable. As Urban already spoke, the ultra wideband can bring the benefit of very accurate and reliable positioning system. And so this customer already had something, but they were looking into getting something more accurate and more reliable. The big thing is that they have 20,000 pallets. So as you can imagine, that is a lot of material to track. And they really needed to find a system that would enable them to do this accurately and reliably. So a little bit of why Budweiser is actually trying to dealing with it is that they keep on growing their production of beer pretty much every year. And second is that they needed to improve on the way their warehouse works, because they do not expand into other territories by building new breweries. They only expand places where they are in the Czech Republic, but at the same time, the area that they can expand to is limited because the brewery is surrounded by other buildings and they cannot build more warehouses and so on. So all in all, they were looking for a higher throughput of their warehouse as well. So as I said, the goals of the projects were to minimize errors, replace the RFID technology that was not good enough for them, to say it plainly, and also to cover, even though I said that Savio platform is aimed for indoor, to cover also parts of the outdoor, because part of the warehouse with empty bottles is outdoor. And obviously to use the data that they gather for analytics and improving of the logistics processes. Now, challenges what they were facing, because it's always good to say that what were the things that they had to overcome, was they've had multiple systems, including different warehouse management system and so on and so forth. So they really had to look into a integration of multiple systems and solutions to work together. At the same time, system that would work indoors and outdoors at the same time, to deal with the outdoor environment, snow and rain. And one of their biggest challenges or things that they were struggling with the previous solution was the cost for service, because the system was somewhat working, but the maintenance costs were too high. This is just a quick picture of what is the sort of landscape of the IT technologies at the customer. They were obviously not working only with location data, but cameras, barcode readers, and so on. There will be a short video that I'll happily show you. So we were only a technology, or one of the technologies that they utilize in order to have the whole system working the way they intended. What were the problems with the legacy system? Well, it was based on RFID, and it worked in a way that the forklift held a RFID antenna on the bottom. And as it was approaching these zones where RFID tags were located, it had to do the reading. And as you can imagine, whatever is located on the floor gets destroyed quite a lot. So the problems were both with the antenna getting destroyed and with the tags not surviving very long. Really, we already discussed this, but they also wanted to make sure that anytime they wanted to change the zones and so on, that they wouldn't need to go through replacing the RFID tags or adding new ones to the floor, which was the situation that with the expansion of the warehouse and trying to increase the throughput, this was something that they would otherwise had to do. So what is the solution? Well, unlike the previous one, currently they have the locator on top of the forklift, and the antennas that, again, Urban already discussed the details, are mounted on the wall, which gives them a very good coverage of the area that they're interested in, and the maintenance of the system is rather low. As I said, pretty much all the challenges that they wanted to overcome in the project, we were able to do with through our partner that took our technology and introduced it to the customer. And also, it gave them all the data for the analytics. What you can see now is a simple drawing of the architecture of the solution. On the bottom part of the picture, you can see the outdoor area. On the top part, you can see where the beer on pallets comes down from the production line. And in the middle, it's the warehouse where they put the finished products, and that's where then they take it to the outside for shipping out. So the solution you've already seen in the very beginning, and perhaps it's very important to say at this point, is we are not tracking 20,000 pallets by having a locator on each one of them, but we have achieved the functionality that the customer has required by simply installing the tag on top of the forklift, and therefore tracking where the pallets go, because they only go where the forklift goes. Now, how does it look like? The pallet is located in one of the zones coming down from the production line. It is moved by these small forklifts to the loading bay. Automatically, it is scanned by the camera so that they know what product goes out, and our location system helps them to see what zone this has happened in, so they really know what product has been shipped at what time. The same thing happens pretty much in the outgoing warehouse. Once the pallet is put down, the driver will indicate that they have put down a pallet in exactly that zone, and the correct position is then sent to the system that stores the information about it. So pretty much all in all, it's a material flow from the production to the warehouse, and then from the warehouse to the outgoing warehouse. There's a simple interface, as you can see on the panel, where the driver is getting instruction as to what to pick up and what to put down. And if the location is not correct, the system will alert the driver that they have picked up a wrong pallet. Because as you can imagine, I mean, the pallets with beer look very much similar to one to another, but it can be a mess up if the order does not contain what it should. So therefore, this was also one of the big goals of the project, to really make sure that the error of wrong shipments is greatly reduced. So what are the analytics that the customer now has with this system? Well, first of them, it's spaghetti diagrams. So they are really tracking whether the forklifts are going in the predefined routes, whether they are sticking out to the plan, and whether they are sticking to the areas where they should go. Also, they're tracking what is the intensity, meaning how often do they operate in particular environment. Therefore, for example, whether they are utilizing all the aisles or whether they are taking some detours and so on. They are also doing one important thing, and that if the forklift stops, they are tracking whether or where is it happening. So is it because they're waiting at the production line for a new pallet to come down, or whether they are taking unnecessary breaks in areas where they should not. What they're also doing is comparing different forklifts and their utilization throughout the shifts, and also throughout different drivers. So for example, they have a KPI to see if the forklift is utilized properly at least 50% of the time, and if not, they try to see as to why is this not happening. This is like a little bit of show how they're realistically working with it. So the interlogistics manager checks the routes of particular forklifts one day after. They're really trying to see whether the pre-ordered activities have been done, or whether there are some deviations to that. Now, what are the results? So the project took 7 months to implement. It was quite short time because there was a little bit of pressure to manage it with the timeline of producing or making the changes in the warehouse, and it brought the two biggest goals that the customer was looking into. One was a higher uptime of the whole solution. From their numbers, the legacy system worked only 80% of time. Now with our system, they are claiming that it's actually 99.9, that they've had very little downtime, and that they can really depend on the system. And second is higher utilization of the warehouse. As they cannot expand on the area, they really wanted to make sure that they are able to track the pallets better. What does that mean for them, for example, is that they are able to stack the pallets consistently on the 3 layers, as you can see, and have the information about what's what and what's where, because before that it was very difficult for the driver, for example, to see what's in the 3rd layer, and therefore this brought really a lot of improvement to them in this area. So why was this customer important, or for this customer to utilize ultra wideband, the technology that we're talking about delivered by Savio? Well, it was high accuracy, high system uptime, and low maintenance. And I would say on a secondary level, it was that they got in the system the possibility to create as many zones as they are interested in, without necessity to install any particular hardware there. And they have the possibility to have an ongoing data gathering and analysis of the data. Lastly, but not least, it's the scalability of the whole system. So very easily, they just add a little, a few more anchors to the system and cover more area if they want to. The second system, or the second solution that can be based on the Savio technology, is eKanban. Kanban is the replacement of the paper Kanban, or the way the production is managed. And so here I would like to talk about company TDK from the Czech Republic. And by the way, we have many customers in other countries other than Czech Republic, but it's just easiest to get references and approvals from the customers to talk about them. So that's why here I have 2 customers from our home country. So what did we do in TDK was the customer was dealing with one big problem. The problem was that they did not have a real-time visibility of what is happening at the very beginning of the whole process, where they pretty much do pressing of certain components at the beginning. And they were in a situation that if this part of the process got delayed, they were looking into the problem that they didn't really have any spare time in the later phases to make up for the delay in the very first phase. And therefore, even they were looking into some penalties that were associated with missed deadlines for shipments. And therefore, they were looking into really seeing what's happening at the very beginning of the whole process. What do we do for them with our partner here in the Czech Republic was, as you can see in the picture, just to give you an idea, they have in the bottom right corner, the pairing zone, where they associate one tag with a particular batch to be made at one of the 50 presses that they have. Once the trolley goes through the green activation zone, the time is being measured so that they will see on the dashboard that I'll show you in the next slide, really whether they are in time, slightly delayed, or very delayed. Now, as then the trolley, the batch, leaves the press, it goes through the yellow deactivation zone, meaning that's where we stop measuring the time, and the tag is unassociated with the particular trolley and a particular batch. So what does it look like? What does the customer really see is they can see these squares or these rectangles with information about particular badges, the weight and when it started, the number of batch. If on that particular press there is already another batch to be made after this one, and they pretty much look. The management of the company looks at only certain things. Is it green? Is it yellow? Is it red? Because if it's red, it means something is going wrong, not according to the plan, and they must interfere or they must do some action in order to fix this. Obviously, it took a little time to understand how the whole process looks like. We did a lot of understanding with whether it all works the way we thought, and then really again, what does the customer see is they are looking as the batches are moving through the process, when they started being at the press, when they left, and whether that's all according to the plan. So this not only gives them the real-time view, but they also have the possibility to analyze the data historically and really try to understand as to why sometimes they are faster than they planned, why it took them longer, and so on. And all of this is based on the simple fact that they are tracking where physically trolley with the batch is, and therefore having the data in order to see, okay, it got delayed because, for example, the transport took long. It was done at the press, but nobody took the trolley to the deactivation zone for it to be moved to the next phase, and so on and so forth. What is really important is for them to have advanced reporting. So that's also what they see. They really look at basically 2 things. One is each press, how that does function, whether it's efficient, and then separate batches. So do they deviate greatly from the standard process or not? And that's it. So to really sum it up, Savio provides a technology through Spitzer for you to take location data and turn it into valuable real-time information in order for you to make decisions faster and reliably. And that's what we offer to you. Thank you very much. And right now I'm open to any questions that you may have. Thank you.
Thank you, Martin. Torej, na Špici imamo tudi druge rešitve za področje skrbovalne verige, torej levo zgoraj rešitve za upravljanje skladišča, torej celovite rešitve. Včeraj je Aleš imel webinar na to temo, zna vam celoti urediti poslovanje, tudi z moduli, kot so recimo glasovno upravljanje. Druga slika, sledenje oziroma označevanje, torej etiketa je še vedno osnova za delovanje oskrbovalne verige. V torek je imel kolega Andrej webinar na temo AMR, avtonomni mobilni roboti, zelo zanimivo področje, veliko tukaj vlagamo in tudi veliko se dogaja na tej strani. Pa tudi desno spodaj vidimo rešitev ePod, Torej, če nas zanima, kaj se dogaja z blagom, ko že zapusti naše skladišče, lahko spremljamo s to rešitvijo, torej naklada na tovornjak, razvoz, potrditev prejema strani vaših kupcev. Zdaj pa kar na vprašanja. We have quite some questions, Martin. Let's start at the beginning. So you all will get presentation at the end of this webinar. What is price difference between technology presented? Martin, will you be able to take this one?
Sure. Well, it's a very broad question because let's put it this way. Ultra wideband is not one technology that beats all the other location technologies, for all use cases. We need to say that. Different technologies in terms of the location data may work better in some environments and worse in other environments, and can be more or less suitable. Because, for example, in retail, and you know this, when you go to a store and you want to buy a t-shirt, you do not really need to know where the t-shirt is located in the store, as long as it's in the store, and you only want to know whether it leaves the store. Therefore, you will have the RFID gates by the entrance, and if somebody tries to take the t-shirt without paying for it, you will get the alarm, right? And so it is a quote-unquote location technology, and the tag is very cheap, but it does not provide you real-time visibility as to where each t-shirt is. While with ultra wideband, the tag price is in tens of euros, and because it's an active component, and maybe suitable for other use cases where you need active component, where you need years of battery lifetime and so on. So I know I'm dodging the question to a certain degree as to what is the comparison.
I agree with you. Price-wise, Martin. I don't think.
But I want to finish this.
Deeply into the case. Okay, sorry.
Yeah. So even though I'm dodging it, sometimes it can be less expensive than other technologies. Sometimes it can be more expensive when you look at the total cost of ownership. But it's a matter of whether the customer does get the benefit that they are looking for with a particular technology or not. So to sum it up, if it was not affordable, we would not have hundreds of customers. So I would say that ultra wideband is very affordable, even though it's still at the, I would say, early adopter stage in the market. It's not as known as RFID or Wi-Fi or Bluetooth, but because of its features, it's making more and more headway into mainstream, and it's definitely affordable technology.
Okay, great. The next one, which technology would be the suggested one to use in warehouse of 2,000 square meters and to use on a forklifts? Based on this question and description, I would say RTLS would be very good fit, but it depends on the business process. Martin, would you like to add anything?
I would suggest that we take this conversation separately with the representative of Spitzer. Let's try to understand what we would like to achieve by tracking the forklifts. What are your goals, perhaps, or what are your problems right now that you are dealing with? Why you would be interested in that warehouse? And yeah, I think it really comes down to understanding what you are dealing with, how that project what would be the benefits for you. And once we know this, then it's much easier to say whether it's ultra wideband or whether you need something else. But yes, I would say that logistics or intralogistics is one of the most frequent use cases that we deal with. So I would say that yes, ultra wideband is definitely suitable for tracking forklifts, even at a smaller area like 2,000 square meters.
Next question is, do you have also a forklift app to use with?
This may be looked into two perspectives. What Savio offers is location data. It's a technology that very precisely gives you information about where the objects are located. And our system produces it in a form of database that can be accessed through API to really take the information to any other system. What we do not have, or what we do not intend on having, is a customer-facing application. This is then a matter of our partners, such as Spitzer, to have either this delivered by some sort of third-party solution, or program it or deliver it based on the particular requirements of each customer. So to sum it up, Savio is sensor data coming from ultra wideband platform, and then our partners, Spitzer, takes the data and puts it to you as the end customer in a shape and form that you require in the project.
Exactly, and we have a team in the R&D department who is able to produce such interface. So next question, what is average price tag to equip one warehouse of 1,800 square meters and 2 forklifts? What inputs do you need to prepare for the offer? I suggest we take this question separately and discuss after this webinar. I think this question is related to Budvar case study. What is the process on inbound? When barcode scanning takes place, is everything pre-planned where to stock the pallet?
No, pretty much the empty bottles come to the outside warehouse, but what they measure, because they know where they are loading and unloading the pallets, is what is, how many empty bottles they pretty much have. If you remember seeing the zones, based on how far in the zone the forklift unloads the pallet, they know how many pallets they have in front. Therefore, they know how many empty bottles are in the warehouse. So there is a certain algorithm that calculates what is the true state of the warehouse. So again, they are able to double check whether their records in the warehouse management system correspond to the location information that they are getting from Savio.
Great. Next one, how can you put data on tag? What kind of data is on tag? So tag is identification data on each tag.
Well, let's put it this way. Every tag has a unique identifier, and the system knows which. The system obviously recognizes one tag from another. Different tags have also the possibility of having different sensors on them, and they are able to send the information from the sensors, such as gyroscope, accelerometer, magnetometer, and so on. And this information is sent through the data channel of the ultra-wideband to from the tag to the anchor, and then anchor sends the information to the server, and server then stores this info or displays it through API, or sends it through API to be displayed. But yeah, has that answered your question? I believe it has. So yes, the system recognizes or distinguishes between tags and their various data coming from it based on the present sensors.
Is the UWB solution appropriate for tracking the movement and the location of trolleys with HEV products in production environment? The question is yes, it is. It was kind of built for. We are talking about several hundred trolleys which transport approximately 500 different HEV products between the operation in production. Mm-hmm. So the question is yes. I suggest we take this one.
Maybe let me put it. Let me expand on that very briefly. The important question is whether, what do you gain by tracking it between the different phases? If it's the time when a shipment the material has been produced, so that you can, for example, initiate, okay, we know it has left a warehouse, so that please make another batch of this because it is going to get consumed by the different phase. So all of this can be automated. And definitely we can track the trolleys in order to provide the input data for such a system. So production running system, of course.
Lahko eno značko UVB znova uporabim za drug produkt. So can I use UWB tag again for another product? Seveda, yes, you can. This UWB is usually used for the closed loop systems, so they are reusable.
But maybe the question is something about whether it works with other systems. So yes and no, in terms of if you're gonna have our ultra wideband tag from to be used in a like a competing environment, it's not 100% compatible between different providers. So theoretically, yes.
It's more about how to reuse it. So
it's definitely reusable, and the battery lifetime is in years. So we definitely, when we think about the tags, it is for environments that they would get reused throughout its life cycle, which is really in years.
Ali ima UVB značka tudi svojo interno logiko, da beleži lokacijo, tudi ko je izven območja kamer. Torej, značka oddaja signal, potem pa je na stvari senzorjev, da zaznajo to značko in določa, koliko časa je signal potoval, in s tem določa lokacijo. Torej, za določitev lokacije potrebujemo oboje, značko in tudi senzor. Okay, we are running out of time and we answer all the questions. So I switch to Slovene. Thank you for your contribution, Martin. Thank you very much. Še eno vprašanje, ali so značke aktivne ali pasivne? Značke so aktivne, torej imajo interno napajanje. Koliko časa zdrži baterija, je pa odvisno od tega, koliko pogosto se ta značka oglaša. Je to enkrat na 100 milisekund, torej 10 na sekundo, je to enkrat na 10 sekund. Ima pa tudi senzor, torej ko se značka premika, oddaja signal, ko stoji na miru, značka ne oddaja signala. Takrat v bistvu ne rabimo videti, kje je lokacija, ker v bistvu vemo, kje se nahaja, ker se ne premika. Hvala vsem za prisotnost, smo na vezi. Izkoristil bi še tole, da vas povabim, jutri imamo še en webinar na temo označevanja, label management sistema. Lepo vabljeni. Hvala vsem. Thank you, Martin. And se slišimo kmalu.
Yes, thank you very much and have a great day. Bye-bye.